Hey guys, welcome back. In this video, we'll code our linear regression from scratch by using our Python language. And in the Python also, we'll be using this NumPy and our Python standard module. Okay, so we'll not be importing anything except NumPy. Maybe we'll be importing matplotlib in order to plot or in order to get a visual representation of our model or how it is performing. Okay, so here you can see that I have created an array, and basically this array is having some elements. These elements, the list that is having two elements. Each of this list is one record. Okay, so when I print this data set here, you can see that this row here is a record. Okay, and since we are just going to see simple linear regression here, okay, so we will be having one independent variable and one dependent variable. Here this column here is a independent variable. Okay, and this column here is a dependent variable. Okay, so this is y in our case and this is x in our case. Okay, so as we have seen in our previous video also, that in order to train the linear regression, we'll be requiring some data. Okay, because this is a supervised machine learning algorithm, so we'll be requiring some data, and the data should be having the independent variable and dependent variable, or output or target variable. Okay, so now we'll create an algorithm that can generate a model which will be able to predict the values of x, values of y for each value of x, right? Okay, so let's get started. I have already done the coding so that we can save some time when we can discuss some other things related to linear regression. Okay, so you can see, so this is the data set that we'll be using. So this is a custom data set that I have created. Okay, hash in Python means the line comment. So when I pressed hash, all these points are just a comment, they will not get executed. Okay, so I have imported NumPy as NP. So now in place of NumPy, I can write NP. So I have created an NumPy array by using np.array, and in this way I have created the record. So basically, if you don't know about the NumPy, let me know. I'll be making some videos, some basic videos, so that you can get familiarity with the NumPy also. Okay, now we'll take this column. We'll take this column out from our data set as an input variable, as our independent feature. Okay, so here you can see that in the data we'll be having this independent feature variable. Okay, and this will be one in case of simple linear regression. This independent feature will be only one, and when we'll be using multiple linear regression, this independent feature can be more than one. Okay, and this dependent feature will be y. So here what we are doing, we are just taking out this independent feature from our data set. So here we have taken the independent feature in our input variable. Okay, so we are taking all the x from our data set such that the value is okay. So we are taking the independent variables from the data set, right? Okay, so this line basically will give this column here to our input vector, to our input variable. Okay, now after that, what we are doing, we are just printing this input variable. So when we execute this, you can see that this column here, we got this column in our input. Okay, in our input variable. Okay, similarly we are taking the output, and this np.array x, this line here, this part here means that it will take the number one, so number one column. Okay, so in np.array, what happens that the counting starts from 0. So this is the 0th column and this is the first column. So in order to get the independent values for independent variable, we are using the 0th column, and in order to get the independent variable values of the dependent variable, we are taking the first column. Okay, so here the output or the target variable, value of the target variable will be on the output, okay, output variable, right? So we have basically prepared this data now. So we have this data now, okay, this data is prepared basically. Now we need to go to the algorithm, okay, now we need to code the algorithm, okay. So this data that we have prepared is basically not required, but in order to test our algorithm, we required this data so that we can see whether our algorithm is producing the correct model or not, okay. So now here we have imported the matplotlib.pyplot as PLT so that we can just show our data point or the model that will generate, or the best fit line that will generate after training our model, okay. So this line here, matplotlib inline, it means basically it means that every time we'll have some plot, the plot will itself be generated in the output, okay. It will not be a separate window, it will be inlined on the output screen, okay. So here I have plot a scatter plot, I have plot my points in scatter plot. So these are the input, these are the outputs. So for x, the value of y is plotted, so it will be like x comma y, 2 coordinate system plot, okay. So you can see that my plot is like this. So all these data points, this data set is basically showing some sort of linear relationship, you can see, okay. So as I told you that whenever we use linear regression, we assume that there is some sort of linear relationship between independent variables and dependent variable, okay. So here by just looking at this, you can see that there is some sort of linear relationship between x and y, okay. So this axis here is x, this axis here is y, okay. Now here comes our algorithm. So basically we are making this class here, okay, and this class will be so guys, I'll not talk about the object oriented programming, but if you want to have that tutorial also, you can just comment down. I'll be making a separate video, maybe 2 or 3 videos on object oriented programming, okay. So here we have created a class regression definition, basically the constructor definition will be there, okay. Here you can see that we have taken the iteration as equals to 10. So this is the default initialization for the parameters of the class. So if we'll not define 10 here, every time we'll be whenever we will create an object of this class, we'll be required to provide some sort of argument or some sort of value to this iteration variable, okay. But all the variables here are by default assigned a value, so no need, we will not be required to pass any sort of parameter to our class at the time of creation, to our object at the time of creation, okay. So now you can see that I have taken the iteration and learning rate. This LR is nothing but learning rate, and there is degree. So basically this class is about polynomial regression also, but since I have declared a degree as equals to 1, so this variable is basically not relevant in this case, okay. But in the future, when I'll be creating polynomial regression algorithm, we'll be using this degree parameter also, okay. Now you can see that I have taken weights here, okay, and bias, okay. So as in our model, we were required some weight and bias, okay. This is weight and bias, okay. So because we have only one independent variable, we'll be needing only one weight. If there would have been 2 independent variables, then model would have been like a1 x1 plus a2 x2 plus b. So we would be having one bias, and these 2 variables, these 2 a1 and a2 would have became the weight, okay, and x1 and x2 would have been the independent variable in that case. But since we are talking about the simple linear regression, we'll be having only one independent variable. This is the case of multiple linear regression or multi-linear regression. Okay, and as step 1 says that we need to assume some weight and some bias in the initial iteration. So we'll do the same. We'll just assume. Here you can see that we have taken these weights and bias as none, and when we are trying to fit a model, we are first taking the shape of the input. Okay, so whatever the input that we have in our this data set, we are having an input of this particular attribute. Okay, so what will be the dimension of this? This is a single column. Okay, so this will be number of records cross 1 will be the dimension. Okay, so how many records are there? 1 2 3 4 5 6 7 8. So 8 cross 1 will be the dimension of this particular input. Okay, so we have our input attributes here, and we'll find the shape. Okay, so this will be the shape. After that, we are printing the shape. Then we are assigning. So guys, remember here we said that we need to assume some weight and some bias in initial iteration. Okay, so here before starting the iteration, what we are doing, we are just going to assume that our weight is 0 and our bias is 0. So np.0 basically is a function in NumPy library that produces a vector of 0 entries. Okay, so the size of the vector will be of n features, and in our case, what is the number of features, or what are the number of attributes? Only one is the number of attribute in our case. Okay, now we are just preparing a plot. Okay, so we are by using our matplotlib library, we are just taking a space, a figure, and we want to add some subplot on that, and we want to basically plot our input and output. The plot will be like this. Okay, so after that, what we'll do, we'll basically start the iteration. So as I told you in my previous video also, that we need to repeat this process again and again until we get the global minima. Okay, until we get the global minima, we will try to reduce again and again, to try to produce new weights and new bias. Okay, so that is why we require the iteration here. So this is basically the iteration loop, and here is our model. Okay, this is np dot input x and self dot weight. So basically we are just multiplying our feature vector, okay, or independent attribute with the weights. Okay, so this model is very similar to our model that we defined. Here you can see y is equals to, so this is the model, is equals to weights multiplied by our attribute plus bias. And similarly you can see here, this np dot means multiply. In case in the case when we'll be having 2 or more than 2 attributes, this dot operator will be multiplying matrices, and it will be producing the values or the equations, this sort of equations. Okay, but for the simplicity, let's focus on only simple linear regression. Okay, so we assume that this input x is having only one parameter. Okay, only one independent variable. So this will get multiplied with weights and then plus bias. This is our model, and after that we need to find the loss. So this is the loss, as we have already got in our previous video. We got this loss. So you can see this is the loss, and this exact formula is written here in matrix format basically. So this is the loss. Okay, so model minus output y. Okay, so output y is nothing but our dependent variable. That is, in our data set, we can see this column here. Okay, this is the output y. Now you can see, now we have our loss function is there. Now we'll update our weights and bias. So this is also the same formula that we have written on our previous video. So we are not going to do this mathematics on the programming part. We'll just write the conclusion. That is the best thing. Okay, so this formula here will be derivative with respect to our weight, and this formula here will be the derivative with respect to the bias, and the same thing is written here. You can see this is the derivative part, and with respect to bias, and this is the derivative part with respect to weight. Okay, and now we are just multiplying it by learning rate, and after that we are subtracting it from the weights, old weights, and similarly we are doing here. Okay, we are subtracting it from the old bias, and then we are printing the iteration number and what is the loss in that iteration. Okay, so this loss will be calculated and it will be reflected back in that iteration, and the new weights will also be printed out, and after that we are predicting it. Okay, so after every iteration we are trying to predict what is the line that we are getting. Okay, so and we'll try to predict, and after that after every 40 iterations we are going to plot a line on our this figure here. Okay, so that we can see what is the line, what is the basically the improvement on the best fit line. Okay, and here is the predict function that will basically take the unknown values and take the x values or independent values for the independent variable, and it will return the predicted value. Okay, so let's run this. Okay, so let's run this. Now we have here regression. So this class regression is used here, and we have created an object, and the name of the object is model. Okay, and we have passed the iteration equals to 200. So this 10 value of 10 will be replaced by 200. Okay, and all the learning rate I have provided here. Learning rate is 0.001 and degree is equals to 1. Okay, nothing new, nothing is there to do. And after that we'll run this. Basically let me erase this, and let's see what will happen when we'll try to fit the given input data to the model. Okay, so this is the basically most important function in every machine learning algorithm. Now you can see that it is learning, and you can see the loss is also getting decreased. Okay, you can see here the loss is 20, then loss is 21, then loss is 20, then loss is 20, 20.99, 20.90, 20.80, and similarly. Okay, so in every iteration you'll be looking that the loss is getting decreases, and we are getting some updated weights again and again. Okay, so I have run this program for 200 iteration, this for algorithm, and after 200 iterations it has given me this kind of output. So this is the model. This is basically the output that the model predicted when this is the best fit line basically that model got after initial 40 iteration, and this is the best fit line that model got after 200 iteration. Okay, then we'll try to predict the same input again so that we can get a pretty visual representation. So you can see that our best fit line is this. Okay, this green one, and if I'll predict the output of this, let me predict for a value. Let's say the value is 6, then you can see that the output is 11.8. By looking at this also, you can see the relationship between x and y is something near about 2x kind of thing. Okay, so if x is 1, the y is 2x. This kind of relationship is followed. And you can see here also, when I tried to predict the value of y for x is equals to 6, it gave me 11.8. that is very close to 12. And if I'll try to predict the value of x for 150, then it should be very close to 300 something. Let's see. Okay, so it is literally little bit close to 300. 280 is the value. Okay, so this is it. The source of this program will be basically available to you. I'll basically give you the link of this this algorithm and this program itself. Okay, my GitHub link will be pasted over there. So make sure that you give star to my GitHub repository, and make sure you like this video if you find it a little bit useful, and just subscribe to the channel so that I can produce more videos and you can get benefited from those videos. So basically this is the starting point of this whole tutorial series. I'll be explaining in much more great details in the further videos, when I'll be explaining about other algorithms like SVM, Naive and decision tree. So this is it for today.